Hey guys, Reed here. I was gonna do questions 2B and 2C from the last problem set number 2. I don't really have a good way to videotape this, so I just gotta hold my phone and hopefully this will suffice. So, number 2B is terminal velocity. We're asking for terminal velocity. And terminal velocity, right, is when the force of gravity pulling you down is equal to the force of drag pushing you upward. So then your acceleration would go to 0, correct? So then you just be falling at a constant velocity. And then the force of drag is equal to the equation that Pete gave us, which is 1/2 rho, which is air density, velocity squared multiplied by your area of either yourself or your parachute, times by the coefficient, and then times by your direction. And in this, since we're trying to find the terminal velocity when we are at sea level, so when rho is at sea level, we have a density of 1.29 kilograms per meters cubed. And then also we are assuming that the combination of the area and the coefficient when we're just using our body is 0.4. And then the last piece of information we're going to need is to find our force of gravity, which in this case, because I'm assuming that I am 70 kilograms, 70 kilograms multiplied by gravitational acceleration, which is 10 meters per second squared, which then would result in 700 newtons downwards. So what we need to do is we need to take this force, right, and find it when it's equal to this equation. So we'll take 700 kilograms meters per second squared is equal to 1/2 p v squared. Sorry, not p. That's not p either, that's rho. For all you fraternity guys out there. That would be 1.29 kilometers per meters cubed, velocity squared, and then 1.4 meters squared. So now we just need to use our nifty algebraic methods and solve for v. So, and just right off the bat you can see that there's kilograms on both sides, so those cancel. Meters squared and meters cubed, that meter squared would cancel, leaving you with just 1 meter on the bottom. And then I like to bring the 2 over, so that'd be 1400 meters per second squared is equal to, and then I said, this is roughly 0.3, that's a little less than 1/2, so, 0.3 divided by 2, or 1.3 divided by 2 would be, 0.65, and then since this is a little less than 1/2, I just made it nice, 0.5 over meters times our velocity squared. So then this would make that 2,800 meters squared over second squared is equal to velocity squared. And then, so then velocity would be equal to the square root of 2,800 meters per second. And 2,800, I argue that, 50 squared would be 2,500, so maybe we could just say that could be equal to 52 meters per second. And this is when we run when the force of gravity is equal to force of drag, so that would be the maximum speed that we would attain, and we would continue at that speed. So that's B, and then if we go to 2C, we would see a man, or me, I guess, on a 3-meter cliff, right? And we want to see how fast I go. Oops, I'm sorry. How fast I go down. And there's an equation on that formula sheet that is your final velocity squared minus your initial, or v naught, velocity is equal to 2 times acceleration times your change of x, or your displacement, right? And in this case, we know that our initial velocity is 0, so that is irrelevant. And we're looking for our final velocity, so we can say v squared is equal to 2, right? And then we know the gravitational acceleration is 10 meters per second squared, multiplied by delta x. Delta x is 3 minus, or we're traveling 3 meters, so that's going to be 3 meters. So then v squared is equal to 60 meters squared over second squared. So then v would be equal to the square root of 60 meters per second. And I said that's, let's say, the square root of 64 is 8, so I would argue this to be somewhere in this ballpark. 7.7 meters per second. So then now we want to know how big our parachute needs to be in order to attain this terminal velocity. So again, we use the previous equation, 700 newtons, right? That's the force of gravity, would be equal to 1/2 times the density at sea level times our velocity squared, right? And then multiplied by A, and then with the parachute, it is given that the coefficient is 1. So we see the equation. I can actually turn this sideways. So then, similar to last time, we use our nifty algebra. So that's going to be 700 kilograms meters per second squared is equal to 1.29 kilograms per meters cubed, multiplied by 60 meters squared over second squared, and then A, right? So then I again moved over the 1/2, and again we see the kilograms, right? Those cancel. The meters and the meters squared cancel. The seconds cancel. So then we're left with m, right? M over here and m down there, which is nice because we want our final answer to be meters squared. So this is a good thing. And then we have 1.29 times 60. You can say what is a third of 60? 20. So 20 plus 60, I would argue, would be 80, right, over meters A. So then we would have 1400 over 80 meters squared is equal to A. You can get rid of the zeros. 140 divided by 8. If you multiplied 8 by 20, that would be 160. So you subtract you subtract 2.5, and you would get 17.5 meters squared is equal to A. So, I hope that was helpful.